This project presents a computational facade optimization workflow developed to rationalize complex double-curvature geometry while preserving the original architectural intent. In this video, you'll see how parametric systems transform design complexity into fabrication-ready solutions. The process begins with the full building model. A specific facade zone is identified, isolated, and extracted for detailed computational study and optimization. This selected facade zone contains complex, non-uniform double curvature. Through computational rationalization, the system identifies the closest fit geometric logic, reducing randomness while minimizing deviation from the original design. Multiple optimized geometries are evaluated to achieve repetition, continuity, and constructability. From the original architectural IFC model, facade panels are extracted as discrete elements. Initially, all 168 panels are non-repetitive, requiring 168 unique fabrication modes. Using clustering, geometric unification, and deviation control, the system reorganizes these panels into only 2 reusable mold types. This optimization significantly reduces fabrication cost while maintaining fidelity to the original surface. Final validation measures geometric deviation across all panels. Deviation ranges from approximately 1 to 68 mm within design tolerance. The result is a rationalized, fabrication-ready facade system. Thanks for watching.